What's up, you guys in Algebra 2 World? Hello, Mr. Pike, calling from wherever I'm calling from again. You'll never know.
You'll never know where I am.
All right, in this video, I'm going to be talking about Section 1-3, function operations. So, especially in the business world and in engineering, whenever you guys get into those worlds, you will see that we can actually do different things with different functions. We've been messing with functions in the beginning to units, just telling what they are, like if they're quadratic or linear or whatever. So like, yeah, that would be a linear function, that would be a quadratic function, but no, don't tell them too much. Oh no. But we can do different things with different functions. We can actually do them to a lot of different functions, but we're only going to be messing with 2 at a time for you guys right now. Just kind of get your feet wet. So f plus g of x is when we would be adding the function f of x with the function g of x. F minus g of x is f of x minus g of x, subtracting those two functions. F times g of x is f of x times g of x, multiplication of those two functions. And this one right here, this is kind of weird. It's a new one. Yes, well, they're all new, but yeah. This is read kind of, oh, that's not supposed to be parentheses, but it is. It's okay. This reads f of, it's a little open multiplication type thing, but it's not really multiplication. It's just like an open circle right there. So f of g of x. So this will read f of g of x. I'll show you how this works in just a minute. All right, we're going to look at our first example. We're going to do all of these parts, but I'm going to cover it up right now so you can see all of these parts. We're going to do that first. All right, so take a second. If you need to pause the video, write down the example. You are more than welcome to. So with this first one, we have f plus g of 3. So notice instead of an x like we have in our rules, I now have a 3. So all I'm going to do is I'm going to take f of 3 plus g of 3, whatever those values are, and add them together. So if you want to do this off to the side or wherever you want to do it, f of 3, I know I'm just substituting 3 in for my x value. So 2 times 3 plus 7. Well, 2 times 3 is 6, so I have 6 plus 7, which is 13. So I know f of 3 is 13. Plus, I need to figure out what g of 3 is, so likewise, I'll do g of 3. So I'll substitute 3 into my g function, so it's 3 times 3 squared minus 14. All right, don't forget about PEMDAS. PEMDAS still applies. Always in math, yes please. So we have to do 3 squared. 3 squared is 9. 3 squared is 9. Times 3 is 27, so this is 27 minus 14, which is also 13. Hey, that's crazy. All right, so I have 13 plus 13 is 26. So what that means is that f plus g of 3 is 26. That's all that's asking for. Cool, let's look at the next one. All right, same sort of idea, except now it's subtraction. So subtraction you got to be a little bit more careful with, but still it's the same thing. So I will be doing f of negative 2 minus g of negative 2. So I need to figure out what those values actually are. So f of negative 2 is 2 times negative 2 plus 7. All right, so that's negative 4 plus 7, which is 3. So I have 3 minus whatever g of negative 2 is. Well, that's 3 times negative 2 squared minus 14. So again, make sure you do the exponent first. So negative 2 squared is 4. 4 times 3 is 12, so I have 12 minus 14, which is negative 2. So I have 3 minus a negative 2. Well, essentially that's 3 plus 2, because that negative distributes, makes that plus 2. 3 plus 2 is 5. So f minus g of negative 2 is 5. Oh yeah. Okay, so now we're going to multiplication, still using the same function. So still using that function. F of 1, so f of 1 times g of 1. So I need to figure out what those function values are. So I have f of 1 is 2 times 1 plus 7. That should be 9 times g of 1, which is 3 times 1 squared minus 14. 1 squared is 1 still, times 3 is 3. 3 minus 14 is negative 11. All right, so now I have 9 times negative 11. Negative 99 is what f times g of 1 is. Oh yeah. All right, this next one, we are getting to our function composition. That's what this is called. So just looking at part D down here, I have f of g of 0. So the way that I'm going to rewrite this is f of g of 0. F of g of 0, f of g of 0. Okay, so now PEMDAS still applies. So what that means is I need to do g of 0 first. I need to figure out what my function value for that is. So g of 0 is 3 times 0 squared minus 14. 0 squared is 0, times 3 is still 0. So I have 0 minus 14 is negative 14. So now that I know g of 0 is negative 14, what I do with that is I take that negative 14 and I substitute it back in, because now I know that this is the same thing as f of negative 14, right? Because g of 0 is negative 14. They are one and the same, right? G of 0 is negative 14. So then, all you have to do, f of negative 14, so just take your negative 14, substitute it into your f function just like we know. So 2 times negative 14 plus 7. 2 times negative 14 is negative 28, plus 7 is negative 21. So f of g of 0 is negative 21. All right, last one for here. We have g of f of 0. So now notice, the last one we had f of g, this one we have g of f. Order matters for all of these function operations, so be careful when you rewrite these things. So I have g of f of 0, so I'll write this as g of f of 0. Right, so now first thing, I need to figure out what f of 0 is. So f of 0 is 2 times 0 plus 7. 2 times 0 is 0, plus 7 is 7, so f of 0 is 7. So that means this part right here, f of 0, that is 7. So I want to do g of 7, because f of 0 is 7. So g of 7, so just substitute in 7 to your g function. So that's 3 times 7 squared minus 14. 7 squared is 49, times 3 is 147, minus 14 is 133. So g of f, gaf of 0 is 133. Kapadai.
Oh yeah.
So the other type of thing you will see is like the last ones we saw that we had numbers right here. You'll also have ones where we don't know what our number is, so we're going to actually just add or subtract or do whatever to these functions using our variable. So say we have t plus r of x using these two functions right there. You're always going to be given some functions to use. So what this means is we have t of x plus r of x, and I'm just going to take those two functions and add them together. So I have t of x is x squared plus 3, and r of x is x plus 2. Then just simplify your function. So I have x squared plus x plus 5. That's it. That's really all we're trying to do there. One that's a little bit tricky is subtraction. So again, pay attention to the way things are written. Make sure you follow the order. Here I have r minus t of x. So r of x minus t of x. So now, just be careful with subtraction. R of x, again, is x plus 2. So I have x plus 2 minus what t of x is, and I need to subtract this whole function. So make sure you throw parentheses around because I want to subtract the entire function. Because what that means will happen is that we need to distribute this negative throughout our entire t of x function. So this will turn into x plus 2 minus x squared minus 3. And then it would just simplify and combining like terms there. So we would have negative x squared plus x minus 1. Oh yeah. All right, moving on. T times r of x. So again, order matters, so be careful. So t of x times r of x. That's what this is going to be. So t of x is x squared plus 3. R of x is x plus 2. Make sure you are multiplying all of those functions to both of each other. Multiplying the entire function t of x to the entire function r of x. So that's why I threw parentheses around these things. Because we will have x squared times x, which is x to the third, x squared times 2, so plus 2x squared. Then I need to distribute my 3, so plus 3x. And 3 times 2 is 6, so plus 6. I have distributed everything to everything. They are all combined in like terms as far as I can possibly go. So that is actually everything that I can do. Okay. All right, getting close. Getting close. Yes. Oh, yes. Thank you. Thank you. All right. So now we have, again, pay attention to order. T of r of x. T of r of x. So t of r of x. Yeah. So take your r of x function, substitute it into that spot. So this is the same thing as t of x plus 2. All right, here's where it gets a little strange. So what you're going to do is you need to go to your t of function. This is your new variable. So in your t function, where you see your variable, you are going to substitute your new variable, which is in this case x plus 2. You're substituting x plus 2. Wants t of x plus 2, so substitute that where you see your variable in the function. So this needs to be x plus 2 squared plus 3. Everything else about the function stays the same. The only thing we're changing is instead of x, it says x plus 2. All right, so then when you're working this one out, don't forget, please, that x plus 2 squared means that you need to multiply x plus 2 by itself twice. That's what the exponent is. So you need to distribute. So you have x squared plus 2x plus 2x plus 4 plus 3. So this will come out as x squared plus 4x plus 7 when you combine like terms. All right, we're getting so close. So close, so close, so close. Just have a few more to look at, because I want to show you guys something that you might see. Don't get freaked out by these numbers in front. All you're going to do is multiply those numbers, because remember, we're just substituting our functions here. So we have 2 times f of x plus 3 times g of x. So 2 times what f of x is, well, that's 2x minus 14 in this case, plus 3 times what g of x is, in this case it's 3x squared minus 4. So I will distribute the 2, so this is 4x minus 28, distribute the 3, so plus 9x squared minus 12. Combine like terms, so 9x squared plus 4x minus 40. All right, same sort of idea, but this one is just 4 times g of x, so it's a little bit simpler. So 4 times what g of x is, so 3x squared, that's a 2, minus 4. 4 times 3 is 12, so x squared minus 16. All terms are combined, and they are alike. The last one, I'm going to do another f of g of x for you guys. So this is f of g of x. Oh, yeah! So what I'm going to do is I'm going to substitute my g of x function where I see g of x. So this is now f of what g of x is, which is 3x squared minus 4. Now this says go to your f function, make this your new variable spot, kind of. So in our f function, this needs to be in your variable spot. So I have 2 times that, 3x squared minus 4, minus 14, so minus 14. And then it's just a matter of simplifying these numbers. So I have 2 times 3x squared is 6x squared minus 8 minus 14, which will simplify to 6x squared minus 22. Cool. Hopefully this video has been helpful. As always, I am usually in my room unless it's like 9 o'clock at night, and then I'm probably somewhere else doing something else. So please, 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 please come ask me questions. I will help you as much as I possibly can. I may even draw a monkey on your paper if you're nice to me. Yes. All right. See y'all soon. Bye-bye.